Solve the following logarithmic equation. Log base 3 of x plus 1 minus log base 3 of x minus 3 equals 2. So we have logarithmic expressions here where the argument of the logarithm is a variable. And when that's the case, what we need to do is we need to rewrite this statement so that we have an equivalent exponential expression, and that's going to be easier to solve. Before we can change this from logarithmic form into exponential form, however, we've got to get all the logarithms combined into a single logarithm and then have that set equal to the constant. And that should be fairly easy to do because whenever we have two logarithms that are subtracted from one another, what we can do is we can combine them into a single logarithm as long as they're both of the same base by dividing their arguments. So I could change this into log base 3 of x plus 1 divided by x minus 3. And that would still be equal to 2. Now, when I have this written in log form, I can change it into exponential form. The base of my exponential would be 3 because that's the base of the logarithm. And then the result of a logarithm is an exponent, so the exponent here would be 2. And then that's equal to x plus 1 over x minus 3. So we now have a rational function that we can continue solving. So what I will do next is multiply both sides of this rational by x minus 3. So 3 squared is 9, and then that's going to be multiplied by x minus 3. The x minus 3's on the right-hand side will cancel, so that's just left with the numerator x plus 1. Now distributing the 9, I have 9x minus 27 equals x plus 1. At this point, all I'm trying to do is get the variable x by itself. So next I will subtract x from both sides. So 8x minus 27 equals, since these cancel, that leaves me with just 1 on the right-hand side. And then next I will add 27 to both sides. So when I add 27 on this side, those cancel. And that leaves me with 8x equals 28. And then I just need to divide both sides by the constant 8 to get x by itself. And that leaves me with x equals 28 over 8. But there's clearly a factor of 4 that can go into both of these. So 28 divided by 4 is 7, and 8 divided by 4 is 2. So the reduced fraction would be 7 halves. Now, this is only a potential solution. We'd have to check and see if this solution resulted in the argument of any of the original logarithms being negative before we're certain that it actually is a solution. So to do that, just come off to the side and plug it in. So we would have log base 3 of 7 halves plus 1 minus log base 3 of 7 halves minus 3. So 7 halves plus 1, we don't really need to do a lot of testing with because 7 halves is a positive number. If you add 1 to a positive number, it's more positive. So if you want to go through the fractions, that's fine. It would be 7 halves plus 2 halves, which results in 9 halves. So log base 3 of 9 halves is perfectly okay because 9 halves is positive. We might need to do a little bit more work here in the second one, changing the 3 into something with a denominator of 2. 3 is equivalent to 6 halves. So this would be log base 3 of 7 minus 6 is 1, so that results with 1 half. And it doesn't matter when we subtract these two values if it's positive or negative, it's only if the arguments are positive or negative. Since they're both positive, that is a valid solution to our equation.